Welcome back from lunch. Hope you had a wonderful time downstairs. So, our next speaker is ready. He's the best. And I have no idea how to present him, but let me do it in my own words. So, imagine me staring at the empty Juni chat box, having no idea where to start and what to do next. So, that's where prompt engineering gives in. So, please welcome Baro Sadagorski on stage. Let him introduce himself.
Thank you. Uh, that makes two of us staring at the junior box and have no idea what to do, but we'll kind of figure it out together. It's first time I compete not only with 6 parallel tracks, but also with all you can eat buffet. And clearly I'm losing, but it's not a fair battle. It's okay. Thank you for being here and thank you for having me. I want to present you an idea. And this idea is prompt-driven development. What we try to do is to align ideas, tests, and code. So we have a trust problem. It's very particularly clearly a trust problem with AI. And this is the 2024 developers survey from Stack Overflow. The numbers are here. You can see that more than 50% of developers don't trust AI. Don't trust AI generated code, accuracy of AI tools. And it's not only opinion of people, there are actually studies that prove exactly that. That AI generated code is not great. You can see, for example, in one study they discovered that 65%, 48%, 31% of code was incorrect through different models. It was GitHub Copilot, Amazon Code Whisperer, and ChatGPT. It's also true for others. They are not very accurate. It's not only that the code is wrong, the generated code is actually dangerous. 40% of the code found, of the code that generated by Copilot, 40% have security vulnerabilities. We understand why, because in the end of the day, large language models just generate tokens that they expect to be correct in any particular time after certain existing words. And it basically means that it's like copying code from Stack Overflow without understanding what they're doing, but even stupider. So, of course, the code that it generates is not great. We can ask it to fix the code that it generates, and it will go exactly as you expect it to go. Right? So it generates correct code and then self-correct and then repair buggy code with more bugs. And generally, the explanations of the code that it produces is incorrect, so the fixes are incorrect as well. Basically, it's a self-validation cycle when the validation is wrong to begin with, and then it also reinforced with wrong code and fixes. So yeah, we have a problem. My name is Baruch Sadagorski. I'm at JBaruch everywhere on whatever X, Blue Sky, LinkedIn, and everybody else. And I'm a developer advocate, currently unemployed. If you know someone who looks for a developer advocate, talk to me. My personal trajectory is I started as a Java developer 20 something years ago, then switched with to DevOps with the company that you all know and love called JFrog. You can think about how I mentioned love or not. And spend some time in another company that you know and love called Gradle. And the thing that fascinated me throughout my entire year is developer productivity, and especially developer productivity engineering. And this is how can we, the developers, be more productive, not only by taking naps in the middle of workday, which by the way helps, but actually have something that we can engineer to make us more productive. And this talk is a lot about that as well. Java Champion co-wrote a couple of books, DevOps tools for Java developers, and Liquid Software about the future of software delivery. And the most important slide of this talk is this. If you go to speaking.jbarrow or scan the QR code, you will see a page dedicated to this talk, and it already has all the slides. It has the video, and that's a good reminder to check if the video is recording. It actually is. So you'll have the video and all the links, the survey, all the research, all the books, everything is already there for you. So to make it easy to remember, it's in the bottom of every slide. What happened? I don't know. We're good. It's in the bottom of every slide, and you can go there whenever you like. Let's talk about software design documents. Software design documents is basically how the software is described in our day and age in software development. Product managers describe what they want the software to do, how it needs to behave, how it wants to look, etc., etc. The problem with software design documents that they're right once. Usually they are not revisioned afterwards. They are read maybe once. Maybe someone read them, for sure, not more than one time. And then it's supposed to be understood by other humans, which makes it particularly hard because humans don't really understand each other very well. And they obviously don't. And don't work because humans don't really understand each other, because there are vague responsibility boundaries in the end of the day when we have the end product that it's not exactly as what we wanted it to be. The question is, whose fault is that? Is it the design documents that didn't express it correctly? Or maybe the implementation was wrong? Or maybe there was some misconnect in between? Remember this? This is from a long time ago. It was some kind of a very stupid idea that somehow testers and developers have animosity and are enemies and what's not. I personally think it's bullshit, because the quality people are there to make sure that the quality of our code as developers is good. And this is exactly what we want as professional developers. We want to be proud of our code, which is good. So I don't think this is true. There was another round of the animosity between dev and ops. You might remember that as well. It was the entire thing that the developers write code and then they kind of out of the building, and that poor ops people need to release the crap that developers wrote, and it's hard and it doesn't work and it's not really deployable. And you know what? This is also over. Why this is over? Because DevOps, obviously. DevOps kind of solved that. I think one animosity that kind of remained is this. And that's what I spoke about when I mentioned that there is a lot of misunderstanding going on, a lot of blame going around. In the end of the day, if the software is not ideal as we envisioned it, there is a lot of back and forth about where the problem is. Now, so the trust problem that we have is not only with AI, it's also between people. But with AI, it's particularly bad. And next thing you know is this. Software quality in general is not great. Think about your favorite tools, think about your favorite websites. They are not as you wanted them to be. Tough drop. This is a great joke. Okay. But yeah, sometimes it works magically. Why? Well, first of all, good intentions. In the end of the day, we all want to do what's right. And yes, we might have some friction, we might have some misunderstandings, but in the end of the day, we really try to produce good software, and this comes a long way. We are professionals, so we kind of expect from ourselves and from others to do the right thing. In the end of the day, when we have some code that someone else has written, we assume that there was at least an effort to make it work. We have good procedures around testing quality assurance. We write unit tests. Hopefully you do, I know. And then we have QA processes that kind of verify what we did. And it helps. It's not 100% because software is still not great, but it helps a lot. So sometimes it does help. And end result observation. We look at the code that we write, that other people write, and we give it a thought. So obviously we give the most thought for our own code because this is our baby, we care about it and it's nice. But we also give a thought for others people's code, especially in processes like pull request reviews, like code reviews. This is our job to look at the code of other people and actually understand if it's good, if there are problems, and how we can fix it. Obviously, sometimes it doesn't work. The PR is too large, looks good to me. I don't have time. I'm busy and what's not. But getting back to professionalism and good intentions, generally, we will make an effort to observe the end result, the code that goes to production. Now, with generative AI, there are no intentions at all because it's AI, it doesn't have any intentions. It's obviously not professional, it just guesses the next character or the next word. It generates the tests that checks its own code. So it's by definition not verifying anything. And no one looks at the garbage that it generates because there is so much of it and it's so garbage. And also, we don't feel any obligation to conduct a good code review for AI generated code because there is no calling on the other side that waits for our honest review. It's just code that's generated by the machine. And it's a lot. And we have other things to do. Just definitely no one is going to review all that. So whatever good pieces of how we create software were there now do not exist with the code that generated with AI. So yeah, it is pretty bad. And the question is, what can we do about it? How can we distill back at least some kind of trust in the code that the AI generates? And one of the ideas that can help us with trust is verifiable intent. What if we code in the intent and then we can verify whatever is generated, either written by us or written by AI, against this intent automatically? Now, one of the ways to do it is express intent in tests. Instead of software design documents, actually, we write in test what our software should do. What it does is then, as opposite to software design documents, which is written once and then forgotten, this is always up to date. If we need to change something, then our intent will be up to date and our implementation will have to be up to date. It generates consensus. Once we agreed that the test actually check the intent, then everybody agree on it. Whatever end result is produced, it is what it is because this is what we asked for. And it's machine parsing. There is no human misunderstanding. Did you mean this or that? Because there are algorithms that will check whether those tests pass or fail. And if you think TDD, when you see that, you're thinking correctly. TDD is definitely one way to verify intent. And this is not a new idea. This is an idea from the year 2000, 25 years ago. It was created by Ken Beck to solve all the problems that we mentioned with static software design and make it verifiable. Now, the problem is that the people who should write the intent, product managers, for example, are not really keen to write code. They don't want to write tests. They want to write text. So can we do something with it? How about if it won't look like code? Everything remains the same. It still has all those benefits, but now it looks like text. In order to text to look like to be verifiable, it should follow some structure. And this is what became to be known as behavioral driven design, BDD. Now, BDD is a next evolution of how do we specify verifiable intent first, which is machine readable, but almost sounds like human language. Can be English, there is 100 of languages translations, and there is a structure to it. This is why it's verifiable by the machine, but it's more human. The year is 2006, 20 years ago, when this idea first came, and well, it didn't really catch its on. For exactly the same reason. People who write software design not only don't want to write code, they don't want to write something that even looks like a little bit like. They want to write text. Okay, so the product managers don't want to write tests first, but test first is still a very good idea, right? I mean, if the product managers want to write tests first, the developers will kill it, right? Well, not really. It's not happening. It's not happening because developers are solution based. As a developer, when we see a problem, we don't think about how we're going to test it. We think about how we're going to solve it. We already know how to solve the problem, and we might write the test afterwards, but not before. Another problem is what we do with all the legacy code that doesn't have tests first. Even if we write the test down, it still will be test later. So test-driven development, unfortunately, didn't catch. Not as a common language between product managers and developers, and not even as a best practice for developers, because this is not how the developers think. Suddenly, we have an absolutely awesome way to achieve what we spoke about. We can now try and do what the product managers like, describe software in text, but also make it verifiable and intent first. Product managers define what software should do in their own language for our AI. And then LLM creates specs, which is something that the product managers didn't want to write, but are definitely okay to read because, as a reminder, it reads like English. So it's not fun to write, but it's absolutely fine to read. Specs are reviewed by developers and product managers and design and QA and the ops and everybody, and agreed that their specs actually express what our software needs to do. And boom, we are in heaven. We just created verified intent before we started to write any code. All we need to do now is generate the tests based on this spec. We can review them as well, or we can automatically check that they are compliant to the spec, and then we can write code which can satisfy the tests. And that means that it's satisfied the spec. And that means that it's satisfied the intent, which is pretty sweet. And it works because product managers now write text and not code or something that at least looks like code. And specs are reviewed and agreed by everybody. And then the first text which is software design document, and the specs serve as living documentation. They have to be up to date because otherwise our code won't build. So they are always up to date, and everything else is derived from specs. Now, we can physically protect what we agreed upon from being changed by the coding agent. And we have to do that because if you remember, we spoke about how the coding agent adapted the test for the code and the code for the text. So all of them are garbage, but somehow everything passes. Physically protecting the specs is what guarantees that everything else will be intact and it's exactly as defined. So for me, the prompt-based development, prompt-driven development, the PDD, is the behavior-driven development as it meant to be. And maybe this is kind of the rediscovery of it. We define and agree on intent, and then AI is protected from circular verification because we lock the spec. And then up-to-date context docs, we have an all time, which is pretty simple. Okay, demo. Now, there I'm going to show you two demos. First, prompt-driven development with Windsurf. Windsurf is a VS Code, the open source version of VS Code based IDE that is, for me, as of today, one of the best coding agents out there. Who is familiar with Windsurf? Okay, not bad. It's much less popular and known than Cursor, for example, but it's actually much better than Cursor. And then we will obviously see it in Julia. Now, I'm going to show you a recording because the live demo takes 40 minutes in Windsurf and then an hour and 20 minutes in Julia. So we are not going to sit through that. Instead, we are going to do, I'm going to show you a really sped up version with my comments as we go. All right. So here we go. Those are the rules of the prompt-driven development. You can see here we define for the agent the persona, who they are, and then what they do. Translate the ideas into code through three-stage-driven development. Common patterns, how they should behave. We're talking about phase transition requirements, version control, etc., etc. Here is the living documentation. All the empty files are the intent that is locked in. And then what it should do, how it should work, stage management, what it asks for, what it doesn't, development process, analysis phase. Let's collect, let's generate all the intent. And then specification phase, let's write the specs. And then the implementation phase, let's write the tests and the code. Working principles, stuff like development flow, when to stop, when to continue, when to ask, etc., etc. This is our request. And the request goes through persona, task, and context and requirements. And this is generally best practice for a request. And we tell it, create a simple to-do application in memory only. And then it analyzes the rules. It knows that it should work in phases and start to generate. First thing it generates are the documents. So here are all the docs that are generated, and we can go and take a look. Should we go and take a look? Come on, go and take a look. There we go. This is the active context. This is what's happening now. It says that it knows that it's a new project, no empty directories, and then product context. This will be our software design document, what we want to achieve. Project process, we are at phase 0, initialized version control, and now in phase 1, did all the analysis. Architectural patterns, have some layers, very complicated app has to be architecture, and then technical assumptions, in-memory storage, minimal error handling, etc. Development environment, it suggests we do it in IntelliJ, obviously, although this is actually Windsurf, but it's smart. And then I say, okay, Analysis looked good. I went through all the documents. We agree with product, with ops, with everybody. This is what we should do. Now keep going. The next thing it's going to do is take this analysis and create the specs. The specs are almost like tests, but human readable. Those are the interfaces, and those are the specs. Here's the scenario: how to add a task. Given I have an empty task, when I add a task, then the task list should contain, and then the task should be added. This is machine parsable intent. We can read through it, product managers can read through it, design people can read through it, and then agree that this is exactly what should be done. And the interfaces are empty, obviously, but they also help us to understand what is going on. Test scenarios, another document that we agree upon, those are the tests that should be implemented and then should did it. Now I throw it a curveball. I say, okay, this is great, but I want to make a change. I want to add a main script that will showcase the output. I want to see how it will deal with new requirements after the fact. It does the right thing. It goes and well, this is where we are. This is the active context. Now it goes and adds new scenarios. Well, it's not great because command line interface, it's not what I meant. And you can start thinking about how command line interface is going to work with in-memory only application. Not great, but okay. This is one thing that maybe we missed both as product and technical, and maybe not. Anyway, I give it approval to go forward, and now it starts to implement the code and the test. Now, you saw there was like a red marker and something didn't compile. In the end of the day, it will have to, because we write a test that should pass. And it will iterate until the tests are passed, unless it's just not working. Now I'm going like, I'm done. And then I can ask the model in a chat reflection mode and ask it what happened. Why did you stop? And it go like, well, I am not sure, I shouldn't have stopped. And I interrogate it deeper and I ask, okay, but why did you stop? What in the rules made you stop? And then it will go like, I had an issue with Gradle Wrapper. And I'm like, fine, but issue with Gradle Wrapper is not enough to stop. And then it goes like, you're right, let me continue. And I'm like, wait, don't continue. Change the rules so it won't happen again. And it will go and adapt the rules, make it more stronger language maybe, or add a missing part that will prevent it from happening in the future. And then it will continue with the work until it stops again. And I'm like, okay, now what? And then it starts to be sneaky with me. It's like, I didn't stop, I just paused. And I'm like, no, you didn't, you stopped. Why? We do it again, we check the rules, we find the weak spot in the rules, we iterate on it to make it stronger, and then it will change the rules accordingly and will continue work. And I tell it, make the edits in rules MD. It makes the edit. You can see there is a new, stronger language on non-stopping. And then we can actually, well, it was a little bit too large for Windsurf, so it needs to adjust it a little bit. But in the end of the day, it writes the rules, and now it goes and continue work. It continued implementing the code, obviously, and the tests and everything else. Now, when I'm managed to with the Gradle Wrapper and what's not, and it stopped a couple of more times during, and I just said like, okay, continue. I mean, again, for the demo. If it wasn't the demo, we would interrogate it again and try to find what's going on. For now, I just needed to continue and be done with it. So it like stopped again. But generally, 40 minutes, in the end of the day, we had a working application. Dependencies problems, obviously, because Riddle. But in the end of the day, we're right there. and it should finish right now. There we go. Ah, no fail. Okay, one more. Okay. Oh, it says like I'm done. What do you want me to do? And I don't know. I don't know what to do. You know what to do. You have rules. And it's like, okay, I need to run everything and verify everything. So it does that. You saw all the green check marks. And at the end of the day, hey, buy milk is added to our to-do app. Yay. So yeah. So this is it. That's the idea. And now the interesting part will be obviously to compare it with Junie and see what Junie does with the exact same rules. So here we go. Exactly the same rules, exactly the same prompt. The plan feature is absolutely amazing. I can see how it interpreted the rules and if it did the right thing. And you can see that it does, right? It starts to create the documents, and the documents, some of them are actually nicer in the uh, system architecture. It has diagrams, which is pretty sweet, and etc. Now something weird is happening. Commands, especially Git commands, start to get stuck. And then I have to cancel them manually with the cancel button. And in the beginning, I wasn't sure what it was. I thought maybe it's just finished with the step and couldn't like get to the done message. So I'm like, I had to stop it, but I think we're good for stage one. I approve the stage one, and then we go into stage two, which is requiring the specs. The specs are ready now, and like the requirement is ready, and now you have my approval to proceed to stage two. Stage two is generating the specs. The features are generated amazingly. You can see exactly the same idea. And then you can see the interfaces, which are also great. And the test scenarios. Everything is exactly as it should be. Makes me very happy. And I'm like, yeah, curveball. Remember, one addition is adding main script. Guess what's going to happen now? Anyone? It's going to do implement everything right now to give me the main. It's like, oh, you want the main? Here we go. It actually created the main and then created the entire application because otherwise the main won't work. Well, that's not exactly what we wanted to do. Didn't you try to come? You need all the implementation instead of changing the requirements in order for us to review and then do the specs and everything else. And then it's like, oh, you're right. Well, the Git stuff is stuck again. We're going to deal with it in a second. Here, your listen terminal commands got stuck. I don't know what's going on. Fix it. I want the reflection from you. Junie is not very big on reflection. So instead of trying to understand what's going on, it runs straight into trying fixing stuff. And the way it fixes to run Git commands. Now, I recall there was a great video about using existing prompts or new prompts. And I'm like, okay, maybe it's just existing prompt that's stuck. Let's create a new prompt. In the new prompt, I need to give it a new context. So I go like, okay, analyze where we are and figure out which stage are we, because we need to know how to move forward. And then it tries to do Git again, Git is stuck again. I try to solve it again. And then I'm like, okay, probably we need a new context. And then I will create a new context to fix a Git. And it's like, oh, new project, let's fix Git. Here's a README file of how to fix Git. And like, I didn't need a README file of how to fix Git. Just go and fix it. So we go back and forth for a while. And then it actually does the right thing. Well, Git tag is stuck again. And then it actually analyzes the project and creates a document that describes the current state of the project, which is very cool. We'll see it in a second. It shows me where we are in our PDD process. Where is it? Right now. Yes. So here we go. The PDD adherence report is pretty sweet. It knows exactly where we are in the process, what has been done, and what's not. And I'm like, okay, let's make sure that now everything is according to the end of phase two. which is exactly where we should be. And again, it will give us a plan of what to do. Well, stack again, start again, new request, and then it will create the plan of how to do it, and we'll check, we'll add the missing spec for our main script and do everything as it should. Okay, adjust everything as it should be, and eventually everything is great. Updated the requirements. You see the new interfaces, and we have the features, which now include the main over there, and it's actually great. Now, let's add the main script that we wanted to the requirements. Now it does something very fun. You remember how it created the main and then I told them not to? It creates the main again. And then it goes like, oh, I should have created the main. And then it deletes it. And then it's like, oh, but we need main. And then it creates the game. But now it is actually all empty with Springlets. Brilliant. This is great. So, I mean, probably shouldn't have created it all, but this works. As long as it doesn't have a limitation, this is kind of a spec, which is okay. And then we continue from there, and it actually goes smoothly from here all the way to the application that it actually works. Start to be a little bit short on time, so I will skip the rest of the demo. Trust me, it actually goes all the way, implements everything, including main, including everything. Yeah, there are some stuff that is not compiling. And then it adds an identifier and it becomes compiling, which kind of brings me to a question that I will get in a second. But I think we can skip the rest. All right. So the rules that I showed you basically are the essence of the prompt-driven development. As you saw, they're mostly written with Cascade, with Windsurf, using the Claude Sonnet 3.7 thinking, which is the most advanced reasoning model we, the peasants, have access to. And the full version covers both existing and new code-based scenarios. So this was the process for new code base. Existing code base will be slightly different. We might want to add a link to those rules to our documentation of the project, because it is important to express how our project was created. And the difference between new project and existing project is the following. So new project, define requirements using the Memento pattern, and the Memento pattern is basically keeping the context of the project in those documents that I showed you previously, the technical architecture, the requirements document, and all that. And then define test scenarios and specs, and then implement tests and business logic. That's exactly what it is. Existing project will have one step prior, and it will be examine the current code and produce full text coverage. Once we did that, we can actually lock those tests, banning the AI from changing anything in those tests. And this is how we guarantee that when we iterate on new functionality in an existing project, the existing functionality won't be broken. Protection rules. Basically, the required documents are protected after stage 1. Once we agreed on the intent in the documents, no one can ever touch them unless we want to change them. And if the changes are needed, the phase will be reset and we will get back to the drawing board. Test scenarios and specs are protected after phase 2. Once we agreed on the specs and which test needs to be done, again, the AI cannot touch them and cannot change the behavior that we want our application to do. Recovery rules, we commit, no, not we. AI has to commit after stages, and this is how we can get back if something goes wrong. And if requirements changed in the middle of the cycle, we go back, reset the phase, and realign. Sometimes we'll just go back to the drawing board and delete everything. Sometimes we might decide that now what we already have will be an existing code base, and we just switch to retrofitting instead of writing new code. So there are pros and cons that you might notice, and I definitely noticed when I worked on this demo, both in Cascade, in Windsurf, and in Juni. So for Cascade speed, it was literally twice as fast comparing to Juni. The most important benefit is the conversation and reflection. And this is critical because I want the AI to govern itself when it comes to how it behaves, why it adheres to rules, and why it's not. And it only can be done if it can examine what it did and we can back and forth about it. Another very nice feature are selectable models. You can select from a lot of different models in Windsurf, and the one that works the best with PTT is Sonnet 3.7 Thinking, but you can select any other as well. Well, the biggest disadvantage is that it's not intelligent. When it generates code, I don't mind. For me, it can generate it no. But when I need to read this code and understand this code, obviously not being intelligent is really painful. At least for me personally, I have much harder time understanding what's going on. The rules are defined in .Windsurf rules, and then there is also memory on top of that, and the rules have a limitation of 6,000 characters. It's definitely not ideal, and I hope it will evolve. Pros and cons of Juni. So the pro of Juni is obviously that it is intelligent, and it's obviously the best tool for writing code as of today. So having an agent in this IDE that I can look and work with definitely helps. The execution plan is absolutely brilliant. I can see if what it does and about to do is actually following the rules, and I can stop it without waiting for it to actually do their own thing down the road. The guidelines MD is better than the Windsurf rules, at least for a fact that it doesn't have 6,000 characters limitation. At least it's not enough. Maybe it's actually worse because it has it and we don't know about it. But hopefully it's not. The biggest cons are speed, as I mentioned, and the introversion part. The fact that I can't converse with the model is really not great. Interestingly enough, when I saw it, I was thinking about how amazing it is that an AI model absorbed the culture of the company is what's written in it. Isn't it cool? So yeah, non-child reflection mode is definitely one. The speed of rule system, what I would love to see is multiple files for different scenarios, which can be actuated by different triggers and then referenced in each other. I might have an abstract set of rules that applied on always, but then a special set of rules that it only applied for a Kotlin project. And then I need the Kotlin rules to be activated because it's a Kotlin project, but also refer to the general rules in order for them to work together. Again, I might want to include it as a part of documentation, maybe not. That also should be an option. At the moment, the best implementation for rules is Cursor. It's also not perfect, but they actually have nice flexibility around file inclusion and this kind of stuff. So definitely worth the checking of how they did. So the question is like, what's happening when the project is large enough? We have context window, and this context window obviously runs up. I can work around it by creating new prompts, and this is what this Juni video is about. You should create new prompt when you don't really need the follow-up. The problem with the new prompt is that I need to populate it with the context. Yes, I have all those great documents of, all the memento pattern that will be sucked in as a context. But first of all, it takes time. And second of all, so memento helps. But second of all, it can be too big even then. Only the context can fill the entire context window. And then we're out of context window for actually doing any work. If the initial context is too large. And my question is, did we find another argument for microservices? The size of the context window can dictate how big our application can be. And if it cannot be too big, this is a very good reason for keeping the services small, isolated, and then connected with each other. Another question that I had, especially when I saw stuff that is not compiling both in Windsurf and is in IDEA, is who is fixing code? So in Windsurf, it will run, and then it will run test, and then it will see the compilation error. The model will try to understand the compilation error and then generate code that fixes it. But we actually have much better tools in fixing compilation errors than AI LLM networks. This is our code expansions or the linking in Visual Couple. And Leonid mentioned just this morning about how important for the agent the ability to switch from AI generation to tool usage when needed. And this is a perfect example. If we have a Kotlin class that does not compile, use the code inspection to fix what's not compiling instead of trying to guess what it needs to be done with the LLM network. I am not sure if this is how it works, but if it doesn't, it's really how it should work. Couple of words about developer productivity, especially when we are talking about this kind of iterative process. Basically, it boils down to the question, what the developer do while the agent works? We have these stops between phases that requires our attention. But also we have time when the agent just go on and go on. Are we watching it going on? Are we reading what it outputs? Are we switching to read emails? This is where speed is an absolutely critical. Because if it's not engaging, we're going to be distracted. William Mark wrote an amazing book last year based on 15 years of research about attention span. And there are a lot of absolutely profound findings in the book. The one that is most important for us is this. It takes 25 minutes to return focus to a task after interruption. Now, what it actually means is that if a phase of implementation of our to-do list took more than we are able to sit and watch doing, like 2 minutes, and then we got distracted. How long the phase takes now? 25 minutes. It doesn't matter if it's finished in 10. Next time we will look at it, will be in 25. It's an interesting question of what should we do. There is another problem. Sometimes the model just stops. We write rules to prevent it. And you saw it a couple of times. We iterated and tried to force it not to stop when it shouldn't using rules. It doesn't really work because with LLMs, all those rules are just suggestions. It's not deterministic. There is no way for us to actually force it going by using the rules. You know what we can do? It's an agent. We have access to physical code. We can tell it to keep going if it's not at the phase binary. Tell it in code, actually fix it. I have an idea that maybe those stops are actually intentional because the model can go for a year and burn a couple of $1 billion without stopping. And as we have the Brave mode in Julie that will run commands for our terminal, including crazy ones like rm-rf, maybe you should have a reach mode that will let it run until it actually should stop in the end of the phase. Or maybe not. Maybe it's not a great idea. So basically, the idea is that we need to use the tools inside the agents, like the code inspections, and we need another idea might be physically protect the assets, make the files that we want to protect read only, so the model won't be able to touch them. And another thing that I would love to see is machine verifiable stage compliance. The compliance of the tests to the specs and the code to the tests to be done by the tool, by IntelliJ automatically. One last thing that I want to touch is it really too much? I mean, it's freaking to do up. It'll probably take it 30 seconds to generate. Instead, I spent like between the two demos 2 hours to do that. Obviously, this is a very simple example, and the process supposed to answer much more complicated questions. But it also might be too rigid. We lock down things and we won't allow anything to actually change it. Making changes in our current process is the pain. The problem is we cannot trust AI. The reason why we'll lock everything down and make files read only and won't let it touch everything because we don't trust it. So are there other options? I have some ideas, but the time is up. It's up to a next talk, follow up, maybe next year, if you will invite me again. So for summer, prompt-driven development, I think, is what makes behavior-driven development finally make sense. It generates consensus. The features are verifiable all the way back to the requirements. And hopefully we can start trusting AI code a little bit more. There is still work to be done. Early days. We'll see where it goes. And with that, thank you very much. I'm Ejin Baruch. TBD is what we just invented. So tweet about it or post about it. And speaking.j Baruch is where you go for the slides, the video, all the links. Everything is there already. Thank you.